Today what we're going to do, this is section 18.4. And in this section, we're going to begin to look at the graph of these quadratic equations, but we're going to be able to do it by hand. So we're going to kind of discover the formulas with our calculators first, but we're going to do everything by hand when it comes to doing our worksheet and my math lab and so forth. So this y equals x squared, I call it the parent function. Why I call it the parent function? Yes, sir.
Are we going to get all these notes today?
Yes. Yep. We have an hour and a half.
Yeah.
Oh, wow.
Yeah. So it's called the parent function because it's just kind of your main function. If you're not doing anything to it, it's going to be what it looks like. So way back when you guys knew how to graph and you did T-charts. Do you remember T-charts, what that meant? You'd have the equation, and you would plug in the x, do the math, and the y would pop out. And that's the same idea here, okay? If we put negative 2 into this equation, what are we just doing? We're just squaring negative 2. But what is negative 2 squared?
Negative 4.
Not negative 4, but positive 4, okay? So we just made an ordered pair. What was our x value? Negative 2. What was our y value that came out? Positive 4. Negative 1, again, we're putting it into our equation, so whatever the equation says to do to x, we're going to do to x, so we're going to square it. But what is negative 1 squared?
1.
1. So what's our ordered pair? Negative 1, 1, perfect. And then 0 squared is just going to be 0. So what's our ordered pair? 0, 0. And then you're going to see a pattern happen. What happens when we square 1?
Positive 1.
It's still positive 1, right? And what happens when you square 2?
4.
You get 4, okay? So these are 5 ordered pairs that are going to be on our graph, okay? So let's go ahead and plot them. So remember, this is your x-axis, this is your y. It's kind of hard to see, but the origin's right here. So negative 2, 4 means go over to the left 2, 1, 2, and then up 4. 1, 2, 3, 4, and put an ordered pair right there. Put a dot there, okay? Negative 1, 1 means go to the left 1, go to the left 1, but then go up 1 and put a point right there. 0, 0 means we have a point at the origin. We have not moved left or right, so that's going to be there. 1, 1 means go to the right 1, up 1. And 2, 4 means go to the right 2, and then up 4, 1, 2, 3, 4. Okay? And remember the shapes of these graphs, like when you see it all together, it almost looks like a V, but it's not a V. Try your best to make it curvy, like an arch, okay? So come down and then try to kind of curve a little bit and then go up. Alright? So that is the parabola. And it's called the parent parabola because we haven't done anything to it. He's just your normal x squared. We haven't shifted it left, right, up, down, or anything, okay? What is the vertex? The vertex is the point that, I put like air quotes, it's the point. It's not really a point because it's a curve. But the vertex is right here. It's where you go to the left or right, it looks the same, okay? So where's the vertex in this case? That was just at 0, 0. What is the axis of symmetry? The axis of symmetry always goes through the vertex. It's this dotted line that goes right through the middle. Because what's it mean to be symmetric, guys? What's it mean for something to be symmetric?
They're the same.
They're the same on one side as they are on the other. So your axis of symmetry is basically if you were to fold your parabola on the axis of symmetry, your graph would fold on itself, okay? The axis of symmetry is an equation. It's an x equals equation. And it's always x equals whatever the x value is of your vertex, okay? Because it's always going to go to through your vertex, so it's always going to be whatever that x value is. What is your y-intercept? Your y-intercept is when x equals 0. In this case, what is it when x equals 0? That's just 0, 0. But let me show you how we would find that by hand, okay? How would we find a y-intercept by hand? That is when x equals 0. So in our equation, we put 0 in for x, okay? So what was our equation? Y equals x squared. But how do you find a y-intercept? It's where you cross the y-axis. And so your x value is 0, so you simply put 0 in and do the math. Well, what's 0 squared? Just 0. So your y-intercept is 0, 0. So I'm just doing the math for something we already know by looking at the graph, okay? Your zeros of a function are just your x-intercepts, okay? How do you find x-intercepts? It's the opposite. It's when y equals 0. Okay? So again, we would look at our parent function, y equals x squared, and put 0 in for y, and solve for x. So the y-intercept is when x equals 0, and you solve for y. The y-intercepts, or the zeros, is when y equals 0, so you put 0 in for y, and solve for x. Well, how do you get rid of a square? You just take the square root. But what's the square of x squared? X. What's the square of 0? Just 0. So again, this vertex, guys, is where we cross the y-axis and where we cross the x-axis. So they happen to be the same. The last question is just how does the parabola open? Is it opening upward or downward? Upward. Upward, yep. And how you can tell before we even graph it is your A. Notice our A, guys, is positive 1. So if your A is greater than 0, aka if your A is a positive, then it's going to open up. So you can look at your equation before you even do it. And if it's negative 2x squared, you know it opens down. All right, so notice down here, guys, I kind of have everything already stated for you. The parent function, before we shift it at all, x squared is the most basic quadratic you can have. So if our parent function is x squared, the vertex will always be at the origin 0, 0. And how do you have to plot your points? You don't have to make this chart. Please realize, in order to plot our points, all we have to do from the vertex is go over 1, up 1, wherever that vertex may be, because we're squaring, go over 2, up 4, and over 3, up 9. Where are all these values coming from? They're coming from squaring these x values, because it's an x squared function, okay? The reason why I'm pointing this out is because we're not going to always use these charts. We're going to find where the vertex is, and we'll just go over 1, up 1, over 2, up 4, done. We've already graphed it, okay? And it'll get comfy the further we get, okay? Go ahead and flip this over. So what I want you to see is some patterns. So I know these are kind of longer, but they're kind of a discovery. In your calculator, let's graph the parent function y equals x squared, okay? So how do we use our graphing calculator? Is right here you have y equals, so go ahead and click on y equals, and make sure you clear out all your y's. If there's anything in there, go and delete them, okay? So the y equals button is just right here. And what we're going to do is we're going to type x, which is right here next to alpha. It has x, t, theta, n, so type x. And then the square button's right up here above log. Is that okay? X squared? Go ahead and hit graph, and don't freak out if you don't see your graph right off the bat. So go ahead and hit graph. See, mine's weird because I use mine for stats, okay? Yours probably doesn't look like that. So what I'm going to do is I'm going to go turn my stat plot off first. You guys don't have to do this. And I'm going to hit graph, and I still don't see my parabola, but anytime you graph and you don't see your parabola, if you hit the window feature, or excuse me, the zoom feature, zoom, and then see how it says Z standard, it means zoom in to the standard negative 10 by 10, positive 10 by 10. So I'm going to hit 6, and it shows my parabola. Is that what yours guys look like? So I use my calculator for a lot more than just this class, so sometimes I have weird stuff. Is that what your parabola looks like?
No, I got air or window range.
Okay. Let me double check yours real quick. Brianna, did yours come up? Okay. So what we're going to do, quit. And go to your window. Oh, see how you have all that other stuff in there? It's trying to graph all that stuff. Okay? And it can't graph all of it. So make sure everything's cleared out except for what you're trying to graph. Brianna, is yours still weird?
What the heck?
Okay, so yours might be just kind of weird. So all you have to do is hit zoom standard,
Oh my God.
and it just gets you to a normal say, it says, now graph y equals 2x squared in the second spot, okay? So go to y equals again. Keep x squared as x squared, but in y2, put 2x squared and hit the graph and see what happens. It graphs it, and it's relatively the same shape, but what did you notice? It's a little bit skinnier. Did you see how it's a little bit skinnier is in there? So it says, now graph y equals 2x squared and y2. How did the parabola change? It got skinnier. I'll double check yours. And you have a color one, so I like yours a lot. It got skinnier, or more narrow, or however you want to say it. Where's the vertex, though? Where is the vertex still at?
0.
0, 0, right? So the vertex hasn't changed at all. All right?
Never mind.
You figured out? Awesome. Okay, so that A changing from a 1 to a 2 made our graph skinnier. So, do you guys have an idea of what putting a 4 in is going to do?
I'll just make it wider.
Nope. We're still going to get skinny. We're just going to get skinnier. Watch what happens. So in y3, put 4x squared. You see how he's even skinnier now, okay? You go ahead and hit graph, and they'll just shove it in there. So it got even more skinny. Did the vertex change, though?
No.
No, the vertex is still at 0, 0. So what I'm trying to do is I'm trying to make you notice the pattern, all right? So it just says, if your coefficient of x squared increases, what happens to the parabola? It stretches or gets skinnier. Or more narrow, or however you want to say, okay? So if we were to graph 8x squared, it'd be even skinnier. Or 100x squared, it'd be even skinnier. You probably wouldn't even see it because it'd be so skinny, all right? Let's look at what happens if we decrease it, all right? So in our calculator, let's keep the y1 as x squared, but in y2 and 3, let's clear it all out. So we're going to clear out the y2, just hit clear out the y3, hit clear. And let's do number 2 first. It says, let's graph 1/2 x squared. There's not a half button on our calculator, so we just do 1 divided by 2 x squared, okay? 1 divided by 2 x squared. So it's going to graph our normal x squared, but then what do you notice about that 1/2 x squared? What is it? It's not skinnier, it's actually wider, exactly. So it got wider. Did it change the vertex at all?
No.
So the vertex is still at 0, 0. So you're probably noticing the pattern. What do you think is going to happen when we put 1/4 x squared in there? It's going to get even more wide. You got it. So in our y3, let's put 1/4 x squared and graph that. And why I said I like Anna's, I'm jealous of it. You know you're a math teacher when you get jealous of people's calculators. But hers is colored, so every time it graphs one of these lines, it's in a different color. It's really cool. This just reminds me of you. Are you guys too young for like the old school Game Boys? Did you ever do the old school Game Boys where it's like this color?
I always said
Yeah, okay, I was just saying. My students stay the same age, and I just keep getting older and older, so all my references don't make sense.
I get them. All my siblings are
But like all the old school Game Boys were like this color, and then they got like the Nintendo DS, and it's all colored and stuff. So our calculators were kind of going like that. Okay, so number 3, it got even more wide. But our vertex stayed at 0, 0. So again, we're realizing what the pattern is. We're noticing the rule. It says if the coefficient of x squared decreases, what happens to the parabola? It widens. So any number greater than 1 is going to make your parabola stretch. Any number between 0 and 1, like any fraction, is going to make it widen, okay? So the last little thing, and I kind of hinted at this when we were doing the front page, is let's go ahead to our y equals and clear out number 2 and 3 again. Let's keep x squared, but let's do number 2. Let's put a negative in front of it. So y2, make it negative x squared, and let's see what happens when you graph it. So we'll graph your normal x squared first, and just type x squared, so negative x squared, yep. And hit graph, it just flips it, right? And so this just makes it upside down. Is that okay? Flips upside down. Did it change the vertex though? No, so the vertex is still at 0, 0. So, putting in our rule that we know, what do you think is going to happen when we do negative 4x squared? Exactly. So it's still going to be flipped, but it's going to get more narrow because that 4 stretches it out, right? So let's go ahead and put in our y equals button on y3, negative 4x squared, and hit graph. And what you'll notice is it throws it down there in that upside down category for negative 4x squared. The negative makes it flip upside down, but then it's narrow. Okay? So it's upside down and narrow. Or skinny. I'm not like, you don't have to use technical terms. Where's the vertex still though? 0. So we have not shifted it anywhere. We've just been changing the shape in the direction it opens. What do you think negative 1/4 x squared is going to do?
Make it wider.
Make it wider. Yep. It'll still be upside down though, right? So let's go to y equals and let's put negative 1/4 x squared and hit graph. So it's still upside down because of the negative, but then the 1/4 makes it wide. So it's upside down and wide. But our vertex hasn't changed. Alright, so the rule that they really wanted you to make note of is the coefficient being negative. So if you look at number 5, it says, what happens to the parabola if the coefficient's negative or positive? If it's negative, it opens down, right? If it's positive, it opens up. And that's like I said, we're going to be able to look at these equations before we even graph them and know, oh, that opens up or that opens down because our A term is either positive or negative. So A term is the little thing that affects it, the A, right? In our quadratic formula, the A. And that's all it's saying right here, okay? So this is kind of like a rule. Rule number 1 that we just discovered. If A is positive, the parabola is going to open up. If it's negative, it's going to open down. So we just discovered that. If your A absolute value, so whether it's negative 4 or positive 4, but if it's greater than 1, we're going to have a narrow graph, or skinny graph like I've been using. If A is some kind of fraction between 0 and 1, we're going to have a wider graph. So you guys just discovered the first rule, that A affects the shape and whether it opens up or down. All right? So now what we're going to do is we're going to start graphing by hand real quick and show you how we can do this without using our calculator. Okay? So go ahead and flip it over. So notice number 1 looks exactly like we've been dealing with, x squared, but there's a negative 2 in front. So let's go ahead and actually I'm going to I'm trying to think. Okay, let's do the chart and then I'll show you the shortcut, okay? So the chart is always plug your x value into your equation. So we're still going to plug x into x squared and square it to get a positive, but what do we have to do at the end? Multiply by negative 2. So we'll have negative 2 parentheses negative 2 squared. Well, what's going to happen? We already know negative 2 squared is 4, but 4 times negative 2 will give us a negative 8. So on this graph, we're going to go negative 2, negative 8 as our first point. Negative 1, we're going to do the same thing. Then negative 2 hangs out on the outside because it's part of our graph, and then we'll have negative 1 squared. Negative 1 squared is 1. 1 times negative 2 is negative 2. So our second point will be negative 1, negative 2. 0, we'll have negative 2 on the outside because it's part of our equation, and then 0 squared, but 0 squared is 0, and 0 times anything is 0. So our vertex doesn't change, and we knew that, right? Our vertex was at 0, 0 the whole time. And then you're going to just kind of see that symmetry happen when we plug in a positive 1 and a positive 2, okay? The negative 2 hangs out, and we square 1, but what's 1 squared? 1 times negative 2 gives negative 2. So our point's 1, negative 2. And last but not least, the negative 2 hangs out, but we square 2. 2 squared is 4. 4 times negative 2 is negative 8. So 2, negative 8 is our point. So let's go ahead and graph it. So how are we going to graph this? -2, -8. -2 means we go over 2, 1, 2, but a -8 means we need to go down. So 1, 2, and we got to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. -1, -2 means go over 1, but go down 2, 1, 2. 0, 0 is our vertex. It hasn't changed. It's staying at 0, 0. And then 1, -2 means go to the right 1, but go down 2. And then 2, -8 means go down, or excuse me, go to the right 2 and then go down 8. But remember, it's just going to be right on the other side. It's symmetric. So again, we have, try your best not to make it like a V. Try to make it kind of curved. So we have the symmetric parabola going on here. So we're going to be able to answer all these questions, okay? So where's our vertex? Our vertex is always the point where we flip from one side to the other. So our vertex is still at 0, 0. Your axis of symmetry is an actual line. It goes through your vertex. So our axis of symmetry, guys, is still this dotted line that goes right down the middle of our graph. It's still just on the y-axis. So that's still just x equals 0. But remember, guys, that always matches your x value of your vertex. So if your vertex is at -5, your axis of symmetry would be -5. Your y-intercept, guys, where do we cross the y-axis at 0, 0? That hasn't changed. Where do we cross the zeros? That's your x-intercept. Where do we cross the x-axis? That's still just at 0, 0. But this is what's one thing that's new. How does the graph open now? It opens which direction? Down. But notice we could have answered that from the beginning because our A was a -2. So like before we even did our ordered pairs, we'd be like, oh, it opens down. All right. So again, we just want to take our time having to do this chart every time. So I want you to remember this little rule, this little ditty, okay? Plot your vertex first, okay? So plot your vertex first. So we are going to know that our vertex is at 0, 0, okay? And then how do we go from there? You always go over 1 and then over 2. How do you know whether to go up or down? Well, it depends on your A. Since our A was negative, we're going to go over 1 down, over 2 down. How much? It's always going to be those squares, right? So what's the square of 1? 1. What's the square of 2? 4, and so forth. But it's 1 times A. So, because remember, this stretches it. So how could we do this on this one? We would go to our vertex and we say, okay, go over 1, down 1 times whatever our A is. What is our A? 2. So we went down 2. And then go over 2, down 4 times whatever your A is, because that's just the pattern of x squared. What was 4 times our A? 4 times 2 is 8, so that's why we could just do it real quick, okay? I'll show you on this one, because notice on this last one down here, there's no chart. And I'll show you kind of how we do it. All right. Has our vertex changed? No, we haven't learned what happens or what it looks like if our vertex has changed. So where is our vertex still, guys? 0, 0. So let's plot our vertex at 0, 0. So put a big old dot right there in the middle, okay? How are we going to plot our other 4 points? Well, is this going to open up or down?
Down.
Down. How did you know?
Because it was negative.
Because it's negative, okay? Let's just answer that question right now. All right, so typically if it's your paired function, meaning there's nothing in front of our x squared, we would just go over 1, down 1, over 2, down 4, okay? But what do we have in front? We have this 1/3. So we're going to go, this is going to be hard to graph, but we're going to go over 1, down 1/3, okay? 1/3 is barely past the x-axis here, okay? So we're just going to go over 1 and then down 1 times A, so 1 times 1/3. So just kind of make the point like right below it. I mean, 1/3 of a box is barely anything, right? 1/3 of a box, guys, 1/3 of a box. So here's a box. 1/3, I just kind of put my point right below that x-axis, okay? How would we do our second set of points? Well, remember, it's over 2, down 4 times your A. So in this case, guys, 4 times our A is a little bit more than 1, okay? So we're going to go over 2 and then down 1 in a little bit. And we're going to go over 2 and down 1 in a little bit, okay? Because remember, it was like 1.3 repeating. So I went over 2, down 4 times a third, okay? I'm going to go one more time. I rarely go to that 3. You usually don't need to do 3 times whatever, but with this fraction, it'll make sense. So I'm going to go over 3 and then 9 times my A, which is just 3. So I'm going to go over 3, 1, 2, 3, and down 3, 1, 2, 3. And this is kind of just overkill at this point, 1, 2, 3, go down 3. But it's just overkill to get you to see that we have this rounder, wider parabola going on. But really, like I said, I had you star this. You really need to make just 2 moves. Over 1, up or down 1 times A, over 2, up or down 4 times A. And that will get you through this whole section, all right? Axis of symmetry, guys, that has not moved. It's still right down the middle of this guy, okay? So it's still x equals the x value of our vertex, which is 0. Our y-intercept, where we cross the y-axis, is still at 0, 0. And our zeros of our function, which is the x-intercept, is still on the x-axis of 0, 0. So if you have not shifted your graph, you've only changed the width of it, your vertex and all that stuff stays the same, right? We haven't moved it left or right, so we haven't changed the axis of symmetry or anything. To me, this is the boring one. I don't like this one. I like when we get to start moving them around. They're a little bit more fun, okay? So let's go ahead and discover what that will do.